You also get today got liquids and solids. So difference between intermolecular and intramolecular. So intermolecular are between molecules, intra are within molecules. So intra is like ionic bonds or molecular or covalent bonds, while intermolecular are things like hydrogen bonds, dipole dipole, or London dispersion forces. So one more thing, intermolecular forces are like the physical connection, while intramolecular are like the chemical connection, like they're chemically altered. So what do intermolecular forces determine? They determine the physical properties such as physical or boiling points. What determines the strength of the LDF is the size of the electron cloud. It's the size of the molecule, the molar mass of it. If you have a larger molecule, larger mass, then you're going to have stronger LDF. Dipole, dipole. So yeah, what determines LDF? Yeah, size, electron. Dipole, dipole is determined by the polarity. So if you have a stronger polarity, like if you have a more electronegative difference, then that's higher polarity. That means you have stronger dipole, dipole. How is boiling point affected by electron distribution? So again, with the dipole, dipole, if your electron distribution is very polar, then you're going to have a stronger intermolecular force and therefore a higher boiling point. If you do not have that much of a polar, whereas like non-polar, you're going to have a lower boiling point. The three bonds from weakest to strongest. So you got LDF being the weakest, London dispersion forces, which is present in every single molecule. Then you got dipole, dipole, which is just the permanent dipoles, and then you got hydrogen bonding, which is a type of dipole, dipole. Hydrogen bond is just hydrogen bonded to F, fluorine, oxygen, or nitrogen. The four bonds branch from highest to lowest. So the thing with branches is that if you're branched, then you have less like common surface area, so you have lower LDF compared to a unbranched one. So that's like the main difference between that. So yeah, I don't know what it means by rank 4. Maybe I'll just, okay, so it's like, because you got LDF. So LDF would again be the weakest, but you're gonna have branched as the weakest, then you're gonna have unbranched as the second weakest, and then you're gonna go on ion. You're gonna have dipole, dipole, and then hydrogen bonding. What are the arrangements of molecules in each state? How does water differ? So molecules in solids are tightly compact. Liquids, they are, they're less compacted, but they just take up the shape of the container. And then gases are just free floating around wherever they want to go, like in the container. How does water differ? So water is different in that the ice, talking about Drake's, okay, ice is less dense than water. Typically, the solid form of the material will be more dense, but in water it's less dense because the water molecules form a crystalline structure which is more spacious. What are the names of the 6 changes and what transitions do they do? So first we got solid to liquid, which is melting or fusion. Then we got liquid to solid, which is, wait, hold on. Yeah, liquid to solid, which is freezing. Freezing, right? Is there a name for that? Yeah. Okay, so then we got liquid to gas, which is evaporation or vaporization. Then we got gas to liquid, which is condensation. Then we got solid to gas, which is sublimation. And then we got gas to solid, which is decomposition. What is entropy? Entropy is just a way of measuring the randomness or the order of a system. What phase changes lead to a positive? So when you go from, like, let's say solid to gas, you're going to have a negative enthalpy. You're gonna be going entropy. You're gonna be going from more disorder to less. You're gonna be going from less disorder to more disorder. Oh wait, no. So you're gonna have a positive entropy. Is that what it said? I think so. So liquid to gas, you're gonna have a positive entropy. But from gas to liquid, you're going from high disorder to low disorder. So you're gonna have a final being a lower number and the initial being a higher number. So final minus initial, you're going to get a negative number. So negative as negative entropy. What is enthalpy? Enthalpy is wait, let me just make sure. Positive entropy, melting, vaporization, sublimation. Yeah, that's what I said. Okay, so enthalpy is a measure of the change, like the internal heat in the system, just the heat content. Is there anything else I should say? relate vaporization and fusion. So the heat of vaporization, it requires more energy than the heat of fusion, because in order to go from liquid to gas, you have to fully overcome the intermolecular forces between the molecules, while in heat of fusion you only partially have to overcome. Sublimation and vaporization. When you add sublimation and vaporization, wait, no, not add. I don't really know what to talk about sublimation and vaporization. Sublimation is when you're going from gas to, I think it would be the same way going backwards. Like, you have to put, you're gonna get more energy from sublimation, because, wait, what even is sublimation again? Sublimation is from solid to, solid to gas, right? So then vaporization. So you're going to require more energy for sublimation than vaporization. That makes common sense. Okay. Difference between state and path functions. So state function depends on the initial and final state, while path dependent depends on the path. So entropy and enthalpy are state functions, or enthalpy for sure is a state function. It just depends on the initial enthalpy and the final enthalpy. Wait, no, not enthalpy. I mean, like, it means on the state of the beginning and the end, right? So, okay, what does standard enthalpy of formation produce? In that reaction, you have to produce 1 mole of substance. Well, I got this practice question wrong. That's why I put the question there. So, what is a phase diagram? It shows what phases a certain molecule will be at certain temperatures and pressures, and just shows the region of each phase. What is normal MP? It's the temperature for melting point at 1 atm. What is the triple point? It's the point where the molecule will be a gas, liquid, and solid all at the same time. That's the temperature and pressure. What is the critical point? That is the point where a supercritical fluid. Yeah, supercritical fluid. That's where the gas to liquid line ends. And beyond that, you can't distinguish the difference between solid and liquid because it's such a high temperature and pressure. What is special about H2O? It'll have a negative slope for the solid liquid phase line slope. Okay, what is solubility? Solubility is the degree a solute will dissolve in the solvent. Miscibility is the ability for two solutions to mix. So key difference, solubility is solid liquid, I would say, and then miscibility is liquid liquid. Examples, so we got salt and water, and then miscibility, you got like oil and water. So like miscibility, oil and water are not miscible. Solubility, sugar and water are soluble. So yeah, what is viscosity? How does temperature affect it? So viscosity is the ability for a liquid to flow. So like compare honey to water. Temperature affects it in that if you increase the temperature, you're going to be able to overcome those intermolecular forces. By overcoming those intermolecular forces, you're going to have less friction and you're going to have a lower viscosity. So it's an inverse proportional relationship or whatever. Okay, what is surface tension? Surface tension is I don't know, like the bonds at the very surface of the liquid. That's how the water gliders and stuff work like that. So how does temperature affect it? Again, similar to viscosity. As you increase temperature, you're going to be able to overcome those intermolecular forces more easily. So then that surface tension will not hold up. That outer layer will not hold up very strongly compared to lower temperature. What is vapor pressure? So vapor pressure is the amount of pressure that the gas molecules above the surface of water will apply to that surface liquid surface, if that makes sense. So how does temperature affect it? So as you increase temperature, more water is going to leave into gas. So as you increase temperature, you're going to increase the pressure that vapor is putting on the surface, on the liquid surface. So therefore, it is a direct relationship compared to the inverse relationship in surface tension and viscosity. Similarly, if you reduce temperature, you're going to have less molecules moving out from the liquid to gas. So then you're going to have less gas molecules, and therefore you're going to have a lower vapor pressure. What are the 4 types of solid? We got network covalent, we got ionic, metallic, and molecular solids. Two properties of solids, amorphous and crystalline. It starts with A. But didn't got the right one. What is amorphous? Bro, my computer just died right now. Okay, crystalline. So there's crystalline. Wait, I think I have it. Where did that sound come from? So that's an issue. Let me search on my phone. But my phone's about to die too. But anyways, the main difference is that amorphous is, it's like, it's not like perfectly crystalline. It's like kind of random. While crystalline, they're set in specific kind of like structure, and because of that structure, you can define a unit cell. Unit cell is the smallest repeatable unit in a crystalline solid. Now, there's three types of unit cells that we can have. We can have simple cubic cell, body-centered cubic cell, unit cell, and face-centered unit cell. So in simple unit cell, you're just gonna have an eighth of a atom on each corner, and therefore you're gonna have one atom in the unit cell. In body-centered unit cell, you're gonna have one atom in the center with eight eighths of an atom on the corners. So it's just simple plus one. So you can have two atoms. In a face-centered cubic and first-centered unit cell, you're gonna have half an atom on each face. So you're gonna have 2, 4, 6. You're gonna have 6 plus the one from all the eights. Wait. 2, 4, 6. You're gonna have 6 halves, which is equal to 1, which is equal to 3 full atoms, plus 1 atom from the 8 eighths that you have on the vertices, if that makes sense. So again, I'll just simplify it. Simple, you have one atom. Body center, you have two. Hold on. You have 2, and then face you have 4. So yep, that's all for today. Pretty simple. And I'll say, wait, let me see the name of the amorphous thing. It's called amorphous. Okay, amorphous. But this guy talked. I think I'm talking about amyloids, bro. What is amyloids? I don't even know. Steroids for amyloids, maybe. I don't know. Yo, what's scary is like I'm learning so much stuff for this that I low-key know like a lot, and it's kind of scary. Like I just be thinking about the stuff I know now. It's like or if I like listen to like some educational thing or something, I'm like I genuinely understand what they're talking about. Like today I was in the lab, and they're talking about PCR, and I genuinely understood what they were talking about, and it sounds so complicated. But I was like, yo, I'm able to piece that together, so it's kind of scary. But yeah, that's all. I'll see you tomorrow. Goodbye.